Alright, let's go. Number 10. The complexity trap. There is a brutal irony buried inside the rise of every great civilization. The very act of solving problems makes the next set of problems harder to survive. Historian Joseph Tainter spent decades studying the collapse of complex societies, from the Western Roman Empire to the ancient Maya, and he found the same pattern repeating itself across cultures and centuries. Civilizations grow by adding layers of complexity. When a problem appears, they build a new institution, a new technology, a new bureaucracy to handle it. That solution works for a while, but each solution becomes part of the permanent structure, and the structure keeps expanding until it requires more energy and resources just to maintain itself than the civilization can sustainably extract from its environment. Tainter called this the diminishing returns on complexity. The empire, he wrote, could no longer afford the problem of its own existence. What makes this theory genuinely terrifying as a cosmic explanation is how universal it appears to be. It does not require war, plague, or natural disaster. It does not even require bad leadership or moral failure. A civilization can be doing everything right, making rational decisions at every step, optimizing and solving and expanding, and still drive itself off a cliff because the complexity it built to survive becomes the very thing that kills it. Every solution creates new vulnerabilities. Every new layer of infrastructure becomes a dependency that can fail. And when enough layers start failing simultaneously, the collapse is not gradual. It is sudden. Modern analysts who have applied Tainter's framework to our current global civilization point out something unsettling. The early warning signs he identified in dying empires, rising inequality, declining returns on investment, growing institutional dysfunction, the inability of leaders to course correct even when they can see the problem, are not hypothetical futures. They are observable trends happening right now. If this pattern holds across intelligent species throughout the galaxy, then the silence we hear from the stars is not evidence of emptiness. It is the sound of complexity consuming itself, again and again, on world after world throughout cosmic history. Number 9. The inherited predator mind. Intelligence did not evolve in a vacuum. It evolved inside biological bodies that spent hundreds of millions of years competing for survival, accumulating instincts tuned for a world of scarcity and threat. The human brain, for all its extraordinary capabilities, is not a purpose-built reasoning machine. It is an ancient survival apparatus with a thin layer of rational thinking draped over the top. And the survival apparatus does not care about long-term outcomes. It cares about immediate threats, short-term rewards, in-group loyalty, and the dominance of rivals. Paleobiologist Olev Vin formalized this concern in a 2024 study, noting that intelligent organisms carry what he called inherited behavior patterns that are deeply incompatible with the conditions of advanced civilization. These are responses that made perfect sense for a territorial primate fighting over food and mates, but become catastrophically dangerous when that same primate has access to nuclear weapons, engineered pathogens, and autonomous weapon systems. The problem runs deeper than just violence. Our threat detection systems are exquisitely calibrated to respond to visible, immediate dangers, but almost completely blind to diffuse, slow-moving, statistical threats. A rival standing in front of you triggers every alarm in your nervous system. A rising graph of carbon dioxide in the atmosphere triggers almost nothing at the visceral level, even when the long-term consequences are orders of magnitude more severe. This neurological mismatch between the speed of threat and the speed of our instinctive response may be one of the most consistent killers of technological civilizations. We evolved to fight the saber-toothed cat we can see. We did not evolve to respond adequately to the slow unraveling of the systems that keep us alive. And if this wiring is a universal feature of intelligence shaped by natural selection, then every species in the galaxy that reaches our level of technology arrives there with the same handicap. The mind capable of building civilizations may structurally lack the ability to sustain them. Number 8. The resource overshoot ceiling. Every civilization in human history has grown by extracting resources from its environment faster than those resources could replenish themselves. And every civilization that did so eventually hit a wall. The Easter Islanders cut down their last palm tree. The ancient Maya depleted their topsoil and collapsed their agricultural base. The Roman Empire exhausted its silver mines and debased its currency until the economy it depended on stopped functioning. Jared Diamond, who studied dozens of collapsed societies, found a common thread that cuts across all of them. They overshoot the carrying capacity of their environment, usually without realizing it until the damage has already passed the point of no return. He documented how environmental degradation is typically gradual and initially invisible. The forests still look dense, the soil still yields crops, the rivers still flow, until suddenly they do not. and by the time the problem is obvious, it is already too late. On a planetary scale, this pattern becomes even more dangerous because the signals of overshoot get diluted across an entire biosphere. A civilization consuming fossil fuels accumulates changes in the atmosphere over decades. The consequences of that accumulation arrive as floods, droughts, famines, and mass migrations that stress political systems already strained by inequality. Those stressed political systems become less capable of coordinating the long-term responses that survival requires. The ecology collapses and takes the civilization with it. This is not a theory limited to primitive or technologically backward societies. Modern analysis shows that technological sophistication does not eliminate ecological limits. It can temporarily mask them, sometimes dramatically so, by creating the illusion of unlimited growth through the exploitation of energy-dense resources. But those resources are finite, and the thermodynamic bill always arrives. If this ceiling is universal, if every habitable planet has finite resources and every intelligent species grows by consuming them faster than they replenish, then resource overshoot may be one of the most reliable killers in the cosmos. Number 7. The coordination catastrophe. There is a category of problem that gets harder to solve the larger your civilization becomes. Economists call these collective action problems. They arise whenever the rational choice for each individual or group produces an outcome that is terrible for everyone. The logic is clean and ruthless. Every actor does what is best for themselves. No one coordinates. The shared resource collapses. No one is to blame in any meaningful personal sense, and yet everyone suffers the consequences. On the scale of a single village, these problems can sometimes be solved through social norms, reputation systems, or community enforcement. But as civilizations grow, the number of actors multiplies, the social bonds that enforce cooperation weaken, and the problems themselves grow in scale until they become genuinely global. Climate change is the most visible example of this dynamic in our current civilization. Every country that burns fossil fuels gains an economic advantage in the short term. Every country that stops unilaterally while others continue suffers the cost without gaining the benefit. The tragedy is that the problem is perfectly visible and perfectly understood. The math is not in dispute. The outcome is calculable. And still the coordination fails, repeatedly, across decades, because the structure of the problem punishes cooperation and rewards defection. Now extrapolate this to a civilization facing existential-level collective action problems. Preventing an engineered pandemic requires every nation to agree on biosafety protocols. Preventing runaway artificial intelligence requires every developer to accept constraints that their competitors might not accept. Preventing nuclear war requires every nuclear state to maintain restraint permanently, with zero margin for error. These are not problems that intelligence alone can solve. They require institutional structures capable of coordinating behavior at civilizational scale. And those structures, as history demonstrates, are extraordinarily fragile. They collapse under political pressure, nationalism, short-term thinking, and the self-interest of powerful actors. If coordination at civilizational scale is a precondition for survival, and if civilizations consistently fail at it just when the stakes are highest, then the stars may be littered with worlds where everyone could see the cliff coming and still could not agree to turn. Number 6. The technological singularity window. There is a narrow and extraordinarily dangerous window that every civilization must pass through on the path from primitive to spacefaring. It begins the moment a civilization develops the capacity to create weapons of mass destruction, and ends, if it survives, only when it has built institutional systems stable and wise enough to manage those weapons indefinitely. The problem is that the gap between those two events may be impossibly small. We crossed the first threshold in 1945, when we detonated the first nuclear weapon. We have not yet clearly reached the second. In the 80 years since, we have come within minutes of accidental nuclear war on multiple documented occasions. The Stanislav Petrov incident in 1983, when a Soviet early warning system falsely reported an incoming American missile strike, was averted only because one officer chose to distrust his own instruments. The Able Archer 83 military exercise the same year nearly triggered a preemptive Soviet strike because NATO war games were mistaken for actual attack preparation. And nuclear weapons are only the beginning. Biotechnology now allows small teams to engineer pathogens of unprecedented lethality. Artificial Artificial intelligence is developing at a pace that outstrips our ability to understand its long-term behavior. Nanotechnology is approaching the point where it will be capable of self-replication. Each of these represents a new threshold in the same dangerous window, and each one arrives before we have demonstrated the institutional wisdom to manage the previous ones safely. Astrophysicist Michael Garrett published work in 2024 explicitly arguing that artificial superintelligence may be the great filter, the barrier that prevents technological civilizations from surviving their own inventions. The concerning implication is that this window is not a one-time crossing. New technologies keep opening new versions of the same window, each one potentially fatal. A civilization that survives nuclear weapons still has to survive synthetic biology. A civilization that survives synthetic biology still has to survive artificial general intelligence. The window never fully closes. It just keeps opening onto new rooms with new ways to end everything. Number 5. The ecological poisoning loop. Life poisons itself. This is not a metaphor or an exaggeration. It is a documented feature of biological systems operating at scale, and it may be one of the most consistent patterns in the history of Earth. About 2.5 billion years ago, a type of bacteria called cyanobacteria developed the ability to perform oxygenic photosynthesis, a revolutionary metabolic innovation that generated energy by splitting water molecules. The waste product of this process was oxygen, a gas that was, at the time, toxic to most life on Earth. Cyanobacteria did not have a plan. They were simply doing what successful organisms do: multiplying, consuming resources, and producing waste. But the waste accumulated in the atmosphere at concentrations that killed most of the existing life on the planet. The Great Oxidation Event, as it is now called, was Earth's first mass extinction event, triggered entirely by the most successful organism of its era doing what it was biologically optimized to do. The same pattern shows up throughout life's history. Organisms evolve successful metabolic strategies. Those strategies produce waste products. The waste products accumulate to toxic concentrations, and the biosphere resets. In each case, the very success of the dominant life form creates the conditions for its own collapse. Now transpose this logic onto a technological civilization. Industrial societies evolved extraordinarily successful metabolic strategies for extracting energy from fossil fuels. The waste product of that process is atmospheric carbon dioxide. The carbon dioxide is now accumulating to concentrations that are disrupting the climate systems that the civilization depends on for food production, freshwater availability, and political stability. The pattern is identical to the ancient cyanobacteria story, operating at civilizational rather than microbial timescales. What makes this especially sobering as a cosmic explanation is that this is not a story about stupidity or malice. The cyanobacteria were not being reckless. They were being successful, and their success poisoned the world they lived in. Perhaps this loop, life's success generating its own poison, is not a flaw in the design. Perhaps it is the design, a universe-wide reset mechanism baked into the nature of biology itself. Number 4. The short-termism paradox. Civilizations consistently make decisions that maximize short-term benefits at the cost of long-term survival. And they do this not because they are irrational, but because the incentive structures they build reward short-term thinking at every level. A politician's primary goal is to win the next election, which typically occurs within a few years. A corporation's primary obligation is to generate returns for shareholders within a quarterly cycle. A nation's primary motivation in international negotiations is to secure advantages for its current population, rather than for people who have not yet been born. These are not failures of intelligence or morality. They are the logical outputs of institutional systems that were designed, often wisely, to serve immediate constituents. But those systems are structurally blind to consequences that unfold over decades or centuries, and most of the threats that can actually end a civilization operate on exactly those timescales. Climate change unfolds over generations. Soil depletion unfolds over centuries. The risks from artificial intelligence accumulate over decades of development before becoming acute. Nuclear arsenals require sustained political commitment to maintain safely across decades of changing leadership and geopolitical tension. Every one of these threats demands that decision-makers invest resources now to prevent catastrophic outcomes that will only become visible long after those decision-makers are gone. And the political and economic systems that civilizations build are structurally incapable of making that trade-off trade-off consistently. Short-termism is not a correctable bug. It is a feature of how intelligence embedded in mortal bodies within competitive social systems tends to behave. If every intelligent species in the galaxy builds institutions that optimize for the next generation at the expense of the 100th generation, then perhaps no civilization survives long enough to become detectable from other star systems. The universe may be full of civilizations that understood exactly what was happening to them and could not stop it anyway, because no one in power had a sufficient incentive to pay the cost today for a benefit that would arrive after they were dead. Number 3. The evolutionary incompatibility of peace and power. Every organism that has ever dominated its ecological niche has done so through competitive advantage. Competition is not optional in a Darwinian universe. It is the mechanism through which biology operates. The traits that produce dominance, aggression, risk tolerance, tribalism, the willingness to harm outgroup members in defense of in-group interests are not vestigial quirks that evolution has been slowly pruning away. They are actively selected features because they continue to confer survival advantages in competitive environments. And civilizations are fundamentally competitive environments. The civilizations that survived in human history were typically the ones that could field armies, extract tribute, and project power across distances. Cooperation emerged as a strategy within groups, largely as a tool for more effective competition between groups. The cooperative instincts we celebrate as the foundation of civilization were themselves honed by conflict. This creates a deep paradox for any sufficiently advanced civilization. The biological traits that enable a species to reach technological sophistication are often the same traits that make it nearly impossible to exercise the restraint that survival now requires. Philosopher Nick Bostrom has argued that any sufficiently advanced technology eventually provides individuals or small groups with the capacity to cause civilizational scale harm. When that threshold is crossed, the only defense is a level of coordination and mutual restraint that runs directly against the competitive instincts that got the species to that point. It is not enough for most members of a civilization to be peaceful and cooperative. It only takes a small number of actors, sufficiently motivated and sufficiently empowered by the weapons their civilization has created, to end everything. And evolution reliably produces those actors. It has been producing them as long as life has existed. The question for any advanced civilization is whether its institutions can neutralize the threat faster than the technology grows. The evidence from the only civilization we can directly observe suggests this is an extremely difficult problem to solve. Number 2, the silence feedback loop. Here is a possibility that is rarely discussed openly, but follows logically from the Fermi paradox. Suppose the galaxy is genuinely full of intelligent civilizations at various stages of development, and suppose that every civilization that reaches a certain level of technological capability eventually discovers something so dangerous that the rational response is to go completely silent. Not because they are afraid of predatory aliens, though that remains a possibility, but because they have learned that broadcasting your existence attracts threats you cannot anticipate or control. This is sometimes framed as the dark forest hypothesis, after the science fiction novel that formalized the game-theoretic logic. But there is a darker version that goes further. What if the silence is not just a strategy that civilizations adopt to survive, but evidence that broadcasting is itself lethal? What if the act of becoming detectable triggers some consequence that civilizations consistently underestimate until it is too late? Consider the implications. We have been broadcasting our presence into space with increasing intensity since the early 20th century. Radio signals, television broadcasts, radar pulses, military communications, all of it has been propagating outward at the speed of light for over 100 years. Our electromagnetic footprint is now visible across a sphere 100 light-years in radius. We have also sent deliberate targeted signals, including the Arecibo message in 1974 and the Voyager Golden Record launched in 1977. Stephen Hawking repeatedly warned against this, arguing that advanced civilizations with the capacity to reach us would have motivations we cannot predict and power we cannot match. But even setting aside the predator scenario, the silence feedback loop suggests something even more fundamental. If every civilization that reaches detectability ends before it can be detected, the absence of signals is not a mystery. It is the expected outcome of a universe in which becoming communicable and becoming extinct are events that reliably occur together, separated by only the briefest window of visibility in which a civilization announces itself to the darkness and then vanishes. Number 1. The intelligence termination hypothesis. There is a possibility so disturbing that most scientists who have considered it prefer not to dwell on it. What if intelligence itself is the filter? Not any particular technology, not any specific failure of coordination or resource management, but the fundamental property of being intelligent, of being capable of modeling the future, of understanding causality, of building increasingly powerful tools to extend your reach across the world and eventually the cosmos. What if that property, in a universe governed by thermodynamics and natural selection, is simply not a stable, long-term strategy? Evolutionary biologist Lyle Lewis explored this in a 2024 book, arguing that the roots of human extinction are in the same drives that powered human success. Intelligence evolved as a tool for short-term competitive advantage, not for long-term civilizational stability. The capacity to understand consequences extends only as far as the next generation or two in most practical decision-making contexts. But the consequences of technological power extend across centuries and millennia. Intelligence consistently outruns wisdom. The two have never been the same thing, and evolution has no mechanism for ensuring they develop together. Every civilization in Earth's history has collapsed, 100% of them. What we call history is largely the story of collapsed civilizations, with a few survivors whose survival was itself contingent on the collapse of their predecessors. The civilizations that lasted longest were not necessarily the most intelligent or the most technologically sophisticated. They were often the ones that limited their own complexity and consumption, that built in strong cultural constraints against the very competitive and expansionary behaviors that intelligence tends to generate. What this suggests, when viewed from a cosmic perspective, is that intelligence may be a self-terminating phenomenon. It emerges, it creates tools of increasing power, it overshoots the constraints of its environment, and it ends. Not because it is stupid, but because it is too clever for its own long-term survival. The universe is 13.8 billion years old. It has had time for countless civilizations to emerge and vanish. And the fact that we can find no trace of any of them, not a signal, not a megastructure, not a single artifact in the millennia we have been capable of looking, may be the most informative data point we have ever collected. It tells us that wherever intelligence arises in this universe, it burns bright, it reaches outward toward the stars, and then it goes quiet. Permanently, completely, and so far, without exception. I will be sharing more similar videos in the future, so subscribe to stay tuned.